This video explains how to do a linear regression on the TI Nspire CAS CX calculator. First of all, you do need some data. In this case, our classes collected foot lengths and heights for each member of the class. From your home screen, you are going to want to access a document, not your scratch pad. I already have a document open. If you didn't, you could go to New Document. So I'm going to go to my current document. To get to this particular page, you push Control Doc, and you're going to choose Add Lists and Spreadsheet. So it would open up a new List and Spreadsheet. You'd go up here, you'd type the name of one of your lists using your keypad, and then type the name of your other list using your keypad. Enter the values in the list. Just for future reference, if you are typing the name of a list and you wanted to make it 2 words, you would need to use an underscore, and that's the control and the space button. But in this case, I made foot length all 1 word and height 1 word. Now, once you have the data entered in, and what I'd suggest you do is maybe pause the video and put in just a few of these values, the ones you can see here. Just have a little something to practice with, and you can do this with me. The second thing I'm going to do now is to go to Control Doc and enter what's called a data and statistics page. When we're making a statistical graph, we don't use the graph page, we use the data and statistics page. And the first thing you'll see is all these dots. And these dots represent any data that I happen to have in the calculator at the moment. Right now I have foot length, and I have some other things that I've done on this document previously. If you have several sets of documents, this will look or several sets of data, this will look very crowded, but we'll organize it quite quickly. Move down with your cursor to the bottom until you see the cursor turn into a plus symbol, and click. And you'll see a list of any variable names that are in your calculator. So I'm going to choose foot length for my X variable. Notice how the dots have sorted. So these are just all of the foot lengths that I have in the class. You can see maybe this is probably the female foot lengths and the male foot lengths more, and the males tend to be clustered a little higher than the females. If we go over to the right-hand side, or sorry, the left-hand edge margin, and see the plus sign and click it, now we are going to add height here. Now this creates what's called a scatter plot. A scatter plot relates 2 variables, an X variable and a Y variable, both of which are quantitative variables. In other words, they are numerical values. Now you can see when you look at this data that there seems to be kind of an upward linear trend to the data. It's not perfectly linear, but it seems fairly linear. And obviously, as your foot length gets bigger, your height's going to get bigger. If you hover over any one of these dots, it represents an individual with that foot length and that height. Okay, so all different values. You can see here we have a person here that has a fairly large foot for their height. Maybe up here, this is a person who has a fairly large height for that foot length, because there are other people with about the same foot length with lower heights. The next thing we're going to do is called a linear regression. We want to create a line that best represents this set of data. And we'll go into, if you see the video Least Squares Regression, it explains a little bit how this line is created, but right now we're just going to let the calculator create it. You go to Menu and go to number 4, Analyze, and down to number 6, Regression, and you can just push the numbers to select those. And number 1, Linear, mx plus b. And you'll see now, I'm going to move this out of the way just a little bit so we can see it better. You'll see we have an equation with a slope of 3.55506 and a y-intercept of 78.9785 that relates our x values, foot lengths, to our y values. So if we took a person's foot length, multiplied at 3.5506, and then added 78.9875, we would get the value on the line that predicts their height. So we're going to do something a little bit with that in just a moment. Now we're going to open a calculator page and do something else with the regression. If we go to Control Doc and select Add Calculator, we'll open a calculator page. Now I want to stress that you cannot just open a scratchpad page at this point, because if you open a scratchpad page, your scratchpad will not recognize your foot length and height data, because that is not in the scratch pad, it's in a document, and only within that document will that data be recognized. So now we're going to go to Menu again, and Statistics, and Stat Calculations, and Linear Regression, mx plus b again. And now we're going to choose our X list. And if you right arrow, it'll drop down a drop-down menu, and I can choose foot length. And then I can tab down and right arrow again and choose height for my Y value. And notice here it says save regression equation to F1. That will come in handy in just a moment. And then we're going to push OK. And notice we have a lot of information here about our linear regression. If you go up to this line and right arrow over, you will see that our regression equation is in F1. If we go back to the left again here, you'll see that we have our X value, our linear regression. There's our X value, there's our Y value. You'll see the title of the regression that we did, the regression equation, the value for M, the value for B, and two more values called R squared and R, and something called resid. The R squared and R are both values that help us evaluate how strong our linear model is. Obviously, in a linear model, some values it would be potentially possible for every X value to be exactly on the line, but in our case it wasn't. So this R and the R squared value tell us something about how much of the data is closest to the line. And we'll talk more about that. If you look at, there's a video about the meaning of R and the meaning of R squared that will tell you more about that. The residual is a list of values that tell us how far away each of these points is from the line in the vertical direction. So if I went from here all the way up to the line, that distance would be the residual for this point. And we're going to calculate a residual. I want you to type in F1, because remember it said it stored our equation in F1. So we type in F1, open a parentheses, type in X, and you push enter. Notice there's our regression equation. It is stored as F1. That's the name of the function. Notice the function notation. So if I type in F1 and open parentheses, notice it's bold. That tells me it's defined. It's something stored in that variable. I could type in any foot length. So let's say my foot length is 25, and I would get the height that is predicted by this line. Now that might not be the actual height. So let's actually find a value here and do this with the regression line. So let's take this value here I was looking at. This person has a foot length of 28 and a height of 168 centimeters. So I'm going to type in the foot length of 28. And notice that the regression line predicts this person's height to be 178.52. And if we take the actual height minus, so this is taking this height here, minus the predicted height, which is 168, we get what's called the residual. So here's the actual, this is the, sorry, I did that backwards. Scratch that. We're going to delete this. Okay, I want the actual height, 168, minus the predicted height, and I'm just going to up arrow and grab this. This gives me a residual of negative 10.5. In other words, if we look at this graph here, my actual height is 10.5 centimeters below the predicted height. Or we could say that the prediction for a foot length of 28 is 10.5 centimeters above this person's actual height. So a negative residual corresponds to all points below the line will have negative residuals. That corresponds to the predicted height being less than the actual height being less than the predicted height. If we picked a value up here, 28,184, for example, well, let's do this one. Here's 20.5162. So if I go back and put in 20.5, F1 of 20.5, that's what the line predicts that person's height will be. But that person's height was actually 162. So we take the actual 162 minus the predicted. Up here, I'm going to grab that. This person had a residual of a positive 10.14. Now, can you guess what a residual would be if a person's height was very close to the predicted height? Oops, lost my spot there. So if I go to something that's really close, notice here, 27,175. So if I put in F1 of 27, notice 174.965. If I take actual minus predicted, notice the residual is almost 0, because a residual of 0 means the actual and predicted value are about the same. Okay, so that explains what the residuals mean. Now let me just show you a little something about the residuals and what they look like on the graph, but I'll leave the explanation of that until later. So if we are on our graph, go back to our graph and go to Menu and Analyze again. Now you'll notice that before, when we did this, there were certain things grayed out, but since we've already done a regression, now we can find residuals. You can't have residuals unless you already have a regression line first. So if I go to residuals and it says show residual squares. So this says the sum of the squares is 1,527.28. Each of these is called a residual squared. So if I can kind of look at this little one, this is the residual. Here is the vertical distance from the regression line to the point. And then if you squared that distance, it would be represented by the area of this box. So here's a larger residual. So here's this one's a larger residual, so it's a larger square. It's hard to see all of these because the squares are overlapping each other. The line that fits the data best is the line for which this sum of the squares is the smallest number possible. Another thing we can do on our graph, if you go to Menu and Analyze and Residuals, is you can show the residual plot, number 2. This shows a plot of just all the residuals. So it shows 0 represents points right on the line. So these values have a 0 residual. These values have a positive residual. These values have a negative residual. And you can see that they're fairly evenly scattered all the way across, some positive and some negative. And it looks like our highest residual is just a little less than 12, and our lowest residual is pretty close to negative 12. Okay, so that's how to use the calculator to do a lot of information. I want to point out one more thing. Is if I wanted to actually see the values of these residuals, I can go to Variable and go to Stat Resid and push Enter, and it actually lists all these residual values. So I could scroll across and see what all of the residuals are. If I took that Stat Resid and I stored it to a list, only have to make a list first. Let me make a list. So I'm going to call this list, I don't know if I can call it Resid. Let's see if this works. Yep, that works. I can call it Resid. And then I can go back here and store these values to the list, doing Control bar. And if I hit my variable, let's see if I have a list. There's my Resid list. And push Enter. And I can go to my list now. And there are all my residual values. So I can see what all of them are. I think I'll leave that for right now. I wanted to show you how to do things on the calculator as far as the meaning of everything. There's some other videos that go into more detail, and this video is already 15 minutes long, so I think I'd better stop.